It is very important when dealing with quadratic functions that you take note of the form in which the function is written. There are three different forms that I think are very important and you need to learn. The one form that we shall look at today is f of x is equal to ax squared plus bx plus c. We call this the standard form. In the previous lesson, we looked at the completed square form. The completed square form has a very big advantage. If you can write your quadratic functions in this form, then you will be able to tell exactly without working out anything what the turning point is. Because if the equation is given like that, then the turning point just happens to be minus p and q. Now the range depends on the value of a. Obviously, if a is positive, it means your graph is happy. And remember, the turning point is minus pq, which means the range becomes y greater than or equal to q, because q there is the minimum value. If, however, the value of a is negative, then you know that your graph is the said graph. If the turning point is negative pq again, then the range will be given by y smaller than or equal to q, because in this case, q becomes the maximum value. Before we continue and look at examples, I just want to remind you that whereas you could use the table method in grade 9 and 10 to draw these graphs, this will no longer be necessary. This will actually not work well for us because we have so much work to do and we cannot waste our time drawing the tables of values. So please do not use the table method anymore. What we do now in grade 11 is to learn to use the properties of these functions. So we need to understand the properties of the quadratic function and all the other functions that we are going to deal with. So you can say bye-bye to that. Let's go back to the completed square form of the quadratic function. If you are given that function, then you can just read the turning point without working it out. So the turning point is just 3, 2. And obviously the range will be determined by the turning point. In this case, our graph is happy because a is equal to 3, which is positive. So this is a happy graph, which is why we get an answer like this one here. But obviously, you are not going to be drawing these graphs using a software. You're going to be sketching these graphs using your freehand. And so this is how you do it. If you meet an equation like that, you need to understand the turning point is 3, 2. You can see it. You don't need to work it out. The other things you know about this graph, one of them is that the axis of symmetry will be x equal to 3. Now, you know also that the range will be y greater than or equal to 2 because a is positive in this case, because a is equal to 3. So how do you sketch the graph? All you need to do is to draw your x and your y axis, then plot your points, like the turning point is 3, 2. So if 3 is here and 2 is there, then that point there will be the turning point 3, 2. Make sure that it's clear that that point is 3, 2. So if there is need for you to write down the coordinates, please go ahead and write down the coordinates like that. Then use the properties of the shape. The shape is a happy face and it passes through the point 3, 2. And to work out the y-intercept, just let x equal to 0. So if you put x is equal to 0 there, I think the y-intercept will be equal to 29. So we know the turning point is 3, 2, and we also know the y-intercept is at 29. I'll just put it there. That's where 29 is. Now I can draw my graph. So the graph will look something like that. But for this lesson, let's look at the quadratic function given in this form. This is called standard form. This is the standard quadratic form. Okay, so the standard quadratic form, we are not going to be using the table of values. So we need to understand a few things. We need to understand the shape of this graph. We also need to understand the turning point of the graph, as well as the x-intercepts plus the y-intercepts. These will together give us the properties of the graph. So all we need to do is work this out. Now, when you get a quadratic function in this form, it can be found that at the turning point, x will actually be equal to negative b over 2a. We can prove that using the method of completing the square. We will do that one later, not today. So at the turning point, x is equal to minus b over 2a. Now, if you know the value of x, it's easy to get the value of y, because you just take that value of x and sub it into the function that was given there. So let's look at an example. In this example, we are given the quadratic function, and this function is given in standard quadratic form. We now need to draw the graph, and for us to do that, we will need to understand the shape of the graph. So you look at the coefficient of x squared, which is 1, and it is positive. Therefore, we know the shape. Everybody knows the shape should look like that. The other thing that is important is to work out the turning point. Now we know that at the turning point, x must be equal to minus b over 2a. But in this example, a is equal to 1 and b is equal to 4 and c is equal to 1. So we substitute b and a into this. We should get a negative 4 over 2 multiplied by 1, which will give us minus 2. So at the turning point, the x coordinate is minus 2. What about y? If you know x, then you can find y. So all you do is take that x value and sub it into that equation. That is why you end up with minus 2 all squared plus 4 multiplied by minus 2 plus 1. And that will give us an answer of negative 3. So we know the turning point. So the turning point is negative 2, negative 3. The next thing we need to know will be the intercepts. Let's start with the easy one, which is the y-intercept. So to get the y-intercept, you put x equal to 0. If you do this into that equation, you will get y is equal to 1, which means the coordinates of the y-intercept can be written as 0, 1. The other intercept we can look for is the x-intercept. For the x-intercept, remember, let y equal to 0. Now that will give you the equation x squared plus 4x plus 1 is equal to 0. If you solve that, you can use the quadratic formula. If you solve that using the quadratic formula, you will get x is equal to negative 3,73 or negative 0,27. And these are 2 points. The 1 point is negative 3,73 and 0. The other point is negative 0,27 and 0. So we know that our graph must pass through these points and that point as well. And obviously through that point there, which is our turning point. So let's draw the graph. All you need is to draw your x-axis and your y-axis. Then your turning point is -2, -3. Want to assume that -2 is here and -3 is there. So -2, -3 will be somewhere there. It helps to write it down again, just like that. So that is the turning point. We know the shape of the graph. It's a happy graph. The x-intercepts, one is at -3,73. I'll squeeze it somewhere there. Remember, there's no need for scale because you are just sketching a graph. So this is where my -3,73 is. The other one is -0,27. I'll put it here. -0,27 here. Then the y-intercept, remember the y-intercept is 0, 1. And I'll put that one somewhere here. And now I can draw my graph.